Flight controls consist of various services around the aircraft that manipulate the aerodynamic forces on the plane, allowing the pilot to control the aircraft. Aircraft flight controls are broken into two systems, primary and secondary flight controls. Primary flight controls are simply those flight controls that the pilot primarily uses to control the airplane. The three primary flight controls are the ailerons, elevator, and rudder. Secondary flight controls, on the other hand, are used to change the airplane's performance and lighten the pilot's workload. The two secondary flight controls that we'll discuss are the flaps and trim. The pilot controls the ailerons and elevator with a yoke or stick, and the rudder with the rudder pedals. In most general aviation airplanes, as the pilot moves the controls, he or she is moving steel cables or push rods connected through other linkages that physically move these controls. As the control surface is deflected, the airflow is changed, which results in an aerodynamic force changing the airplane's path through the air. Let's investigate the three primary flight controls in more detail. The ailerons are located on the back end of the wings out towards the tip and control the aircraft's roll or bank. When the pilot moves the controls to the left aileron is deflected up, creating a downward force, and the right aileron is deflected down, creating an upward force. This results in the airplane rolling to the left. The opposite would happen if the pilot were to move the controls to the right. The elevator is attached to the back of the horizontal stabilizer and controls the airplane's pitch, which allows the airplane to climb or descend. When the pilot moves the controls forward or aft, the elevator rotates, deflecting the air and creating a force that results in the airplane's pitch changing. If the pilot pulls back on the controls, the elevator will move up, creating a force that pushes the tail of the airplane down, thereby making the nose pitch up and causing the airplane to start climbing. Finally, the rudder, which is controlled by the rudder pedals, is attached to the back end of the vertical stabilizer. As the pilot pushes on one of the rudder pedals, a cable connected to the rudder allows the rudder to move. Just like the other flight controls, as air moves around the deflected rudder, a force is applied, making the airplane yaw. Simply, if the pilot pushes the left rudder pedal, the nose of the airplane will slide to the left. The easiest way to envision this is to think of an airplane suspended on a string above the ground. If you and your friends were to walk up to the rudder and push as hard as you could towards the right, what do you think would happen? The tail of the airplane would move to the right, and the nose would move to the left. It's that simple. We use the rudder in coordination with the ailerons to turn the airplane. The primary flight controls, then, fundamentally work the same. The pilot moves a control in the cockpit, which, through cables and other linkages, moves that control. As that control is moved, the airflow around it gets deflected, creating a force, and results in the airplane either rolling, pitching, or yawing. In order to help improve the performance of the airplane and make the pilot's job easier, most general aviation airplanes are equipped with flaps and trim, known as secondary flight controls. Let's examine these further. The flaps are located on the back side of the wing, close to the fuselage. They are primarily used to help increase lift during takeoff and landing. The pilot controls the flaps by moving a lever in the airplane, which either electrically moves the flaps by a motor, like on the Cessna 172, or the pilot manually moves the flaps using a lever, like on the Piper Arrow. In either case, as the pilot extends the flaps, the shape of the wing changes, which increases lift. This allows the airplane to fly at slower airspeeds and make steeper approaches to landing. This is extremely beneficial during takeoff from a short runway because it allows the airplane to take off at a slower speed, meaning it will use less runway. During landing, the pilot uses flaps to allow the airplane to land at a slower airspeed.